So we're going to start by discussing a guy named Jean Lamarck. We're actually going to discuss him even though his theory has basically been disproved, but we're going to discuss him because he was one of the first people to really think about how evolution might actually be happening. Lots of people before him maybe proposed that evolution was happening, but didn't give any explanation for how this might be occurring, for how organisms are changing over time. So even though what he proposed turned out to not necessarily be correct, he still proposed a bunch of things that are true. So not everything that he said still holds true today, but he did have some really good ideas about how characteristics maybe could be passed on. So his theory was called the inheritance. So inheritance is a word that we'll see quite a bit, but inheritance means being able to be passed on, of acquired characteristics. Now, you might remember, if you remember being in grade 9, which might not be part of your memory for a lot of you, but you might remember the difference between something that was acquired and something that was innate, or something that was genetic, let's say. An acquired characteristic is one that is not genetic. So an acquired characteristic is not one that you are born with, it's one that you develop during your lifetime. So even though maybe we realize now that you cannot inherit acquired characteristics, he did propose a mechanism for how evolution happens, and part of his mechanism, or part of his explanation for what was going on, is still part of the current understanding of evolution. So the first thing he noticed was that in fossils, there was evidence of what we would call a line of descent. And by that, he meant fossils that show progression. So we would be able to find fossils of the same organism, the same species, that over time, and we knew it was over time because some of them were older and some of them were younger, over time showed a change in a characteristic. So I'm going to use the example of a giraffe down here. And what was obvious in the fossil record was that giraffes had a short-necked ancestor. And that current giraffes had long necks. But besides the length of the neck, it was still a giraffe. It was still the same species. So for more than just the giraffe, but for many species, we would see this idea of line of descent, fossils that show progression. In other words, change over time. And so Lamarck said, well, if these fossils show progression, show change over time, then something must be happening to cause that change. And so in his mind, inheritance, or the passing on of characteristics, was based on need or desire, we could say. So according to Lamarck, here's how it would work. An ancestor who had a short neck would be looking for food on a tree and would not be able to find any. So the ancestor would stretch and would stretch and would stretch because they needed to, because to get food that was higher up on a tree, it was advantageous to have a longer neck. So he said that the inheritance was based on need or desire. It was purposeful. And he said that acquired characteristics got passed on. So this is what he said. The organism wanted to stretch their neck. They needed to reach the food that was higher. They would be able to survive if they could reach the food that was higher. So they purposefully, because they wanted to, stretched their necks. And once they had stretched their necks, they could pass this new stretched out neck characteristic on to the next generation. Now this all sounds great. And when you don't have another mechanism, that actually sounds like a pretty plausible way for how things happen. But if this were true, I should be able to, so let's say for fun, learn how to play the piano, have a baby, and my baby should come out of the womb knowing how to play the piano. That would be the logic behind it. I can learn how to do something, and then I pass that characteristic on. And you might say, oh, well, that's just an ability. Everyone knows abilities aren't heritable. So what about a physical characteristic? I should be able to go to the gym and build myself some 24-inch biceps, which would never happen. That's ridiculously big. And then I should be able to have a baby, and my baby should come out with 24-inch biceps. That sounds kind of ridiculous. Similarly, if I have a scar, I should be able to pass that scar on, or a broken leg, I should be able to pass that on. And I say these things, and I see people kind of smiling like that's dumb. You know that you can't pass that on to your child. But at this point in time, right, we didn't know a lot about DNA yet. So we didn't really understand how something could get passed on or not passed on. And since having a long neck was a physical characteristic, it seemed pretty obvious that physical things could get passed on. So, according to Lamarck, because we're going to compare Lamarck to the next guy in line, Darwin, according to Lamarck's theory of acquired characteristics, we could call it the law of use and disuse. So he's basically saying an organism can change its body characteristics during its lifetime. Now that is in part true. That's not false. I can change my body characteristics in my lifetime. I can get a tan, I can dye my hair, I can go jogging, or I can lay at home and eat bonbons and do the opposite of go jogging. But I can change some of my body characteristics during my lifetime. Does that mean that I can actually pass those things on? That's the part of his theory that's the problem. According to his theory, much like I was saying before, if two people are cyclists and they get married, their baby should be a cyclist. That's what should happen because they've used their leg muscles, so they should be able to pass on that acquired characteristic. So the big weakness, we would say in Lamarck's theory, is that we know now that what gets passed on is DNA. And the environment cannot cause directional mutations in DNA. So I cannot be like, hey, DNA in all the cells of my body, could you just change, because I'd like to be taller. So I'm just going to stand on my tippy toes every day until my DNA changes. I can't change my DNA. The only things that can change DNA in any real visible way are some pretty serious things like strong chemicals, genetic modification, which requires a bunch of lab techniques. And even then, you'd have to change all of the DNA in all of your cells. It's kind of a big deal. Changing DNA is not something that happens easily. And so because I cannot do this directionally, like on purpose, I can't make my DNA change to be the way I want it to be. That's why this theory isn't the one that most scientists adhere to, because we recognize that even though you can acquire a characteristic, if it's not part of your DNA, you can't pass that physical characteristic on. Now, does anyone have any questions about Lamarck's theory? So here's some things that he said. We found fossils of organisms that were obviously different over time. They had a common ancestor, and the ancestor isn't the same as what it looks like now. Characteristics got passed on. All of those things are true. The thing that isn't true is which type of characteristics could get passed on, and perhaps why they were getting passed on. But the basic premise of his theory still holds true. So we are going to talk about Darwin and Wallace. You might have never heard of Wallace, which is so unfortunate for him. If you are ever a famous scientist and you make a discovery with one of your buddies and he says, hey dude, let me put my name first because you know it's alphabetical, say no. I will put my name first. That way when people talk about this theory, they will talk about me. So Darwin and Wallace, both at the same time, were researching and discussing this idea of natural selection. This theory of natural selection is the basis of the current model of evolution. So this is the basic principle that the majority of scientists would believe explains how evolution has happened and will continue to happen. So just a little bit about what they were doing. Charles Darwin, who's a pretty famous guy for a bunch of reasons, but he was traveling on this boat. His boat was called the HMS Beagle. It's a trivia crack question, Jeopardy question, Trivial Pursuit question. I learned it at some point and never forgot it. And they were traveling off the coast of South America. So there's a little picture here just showing you a bunch of the islands that they were going to. But they are all just off the coast of South America. So if I was to draw South America, it'd be kind of over here. So they're quite far away from home. Like these are British guys that are exploring the world. But the basic principle, and if you had to sum up what did Charles Darwin say, this would be the basic principle of natural selection. Individuals with traits that help them survive are more likely to pass these traits on. Now we'll talk about why they're more likely, but basically, if you have something that helps you survive, the chance of you producing offspring is better. There is competition for very limited resources, and this competition selects for individuals with favorable traits. You might have heard people at some point call this survival of the fittest. And the word fit has perhaps gotten too specific of a connotation. Being fit doesn't mean that you can run a marathon. Being fit means that for the environment that you are in, you have the right characteristics that will let you survive. So being fit doesn't necessarily mean being really lean and drinking a green leafy smoothie every morning. Being fit means being able to survive in the environment that you are put in. So we will spend quite a bit of time talking about what Darwin said and how he explained that natural selection would happen. And most of what he said is based off of his travels to this area near South America. So for the first of his observations, it says in your textbook, the flora and fauna, now flora means plant life, fauna means animal life, of the different regions the Beagle visited were distinct from those Darwin had studied in England and Europe. For example, the rodents in South America were structurally similar to one another, but were quite different from the rodents Darwin had observed on other continents. So his observation is that rodents in Europe were not the same as rodents in South America. But rodents in South America were similar to rodents in South America. That's what he found. And so his question, or the thing that it says in the textbook, if all organisms originated in their present forms during a single event, which is what philosophers like Aristotle had said, Darwin wondered, why was there a distinctive clustering of similar organisms in different regions of the world? Why were all types of organisms not randomly distributed? So his question then is about distribution. That's what he's thinking about. That's what he's asking himself about. So he's asking himself, why are organisms distributed this way in what seems like an obvious pattern if organisms have not evolved, if things have not changed over time? So that's what I would write as my little summary. He saw that there was a pattern in the distribution of organisms that seemed to have to do with the way that they were and the way that they looked, which didn't really coincide with the old theories on evolution. So remember, at the time of Darwin, we're still in the midst of contradicting old theories on evolution and trying to propose a new one.